Alice has a lock whose combination consists of three integers a, b, c, which need to be entered in that order. The three integers satisfied the following. Each of a, b, and c is between 1 and 40. A, b, and c are different. B is less than a, b is less than c. Of the integers, one of them is 20 and the other is 30. How many possible combinations are there? Okay, let's go through this one by one, see what we can do. First, I'm going to summarize on the side, sort of, I guess, what their conditions are. So A is between 1 and 40. Is that right? Yeah, and so is B and C. Okay, so that seems pretty straightforward. Now, what's the next condition here? We've got, they're all different. So A cannot be equal to B, and that cannot be equal to C. And then B is less than A, and B is also less than C. Okay. And then 1 is 20, and 1 is 30. And I think that's it. All right, so let's see what we can get here. What's the right approach? I'm just trying to see here. There's probably, I don't think there's any kind of formula. I think you just kind of attack it. So, and really the thing that we're going to work with is this right here. Okay, let's try that. I think that's the only way, sort of. Okay, all right. So first what I'll do is I'll let A equal 20 and C equal 20. C equal 30, sorry. C equal 30. And then kind of go from there. And then we know that B is less than A, and B is also less than C. So B has to be less than 20, therefore. And they're all, let me see here, they're integers. Well, actually, this is what kind of tells me what they are in terms of the numerical value. So that means B can be anything from 1, 2, 3, all the way up till 19, correct? That satisfies all of our conditions. So this gives me a total of 19 possibilities. Okay, that's a pretty good start. Now let's go to, what's the other way of doing it? A equals 20. How about A and B? Yeah. B equals 20 and A equals 30. How about that one? Okay, if that's the case, then, and B is less than C, correct? According to this guy right here. So that means that C has to be either 21, 22, and so on, all the way up till 40. So that gives me 19. Another 19 possibilities. So there we go. Okay, moving right along. The next one would, let's make B equals 20 and C equals 30. And then since, let's see here, B is less than A, right? B is less than A. So that means that A can be anything from 21 all the way till 40. So that gives me another 19 possibilities. And then the final one, I think, is C equals 20 and A equals 30. Because some of them, you have to keep in mind, this has to be abided by. So that's why there's we've limited to just these 4. So if that's the case and B is less than C, that means B can be anything from 1 till 19. So that gives me another 19. So there we go. So it looks like 19 times 4 is the total, and that would be 76. For some angles theta, the three numbers 2 minus 2 cos theta, 1 plus sine theta, and 2 plus 2 cos theta form a geometric sequence in that order. Determine all possible exact values of cos theta. All right, so geometric sequence is of the form AR squared, and so on. AR to the power of 3, that kind of thing. That's the way a geometric sequence is. So they're saying that these three guys are like that. So we'll let that one equal A. Did they say? In that order. Okay, that's important. 1 plus sine theta, that's the AR. and the 2 plus 2 cos theta. That is the AR squared. Okay. So to get R, we can just take the second guy and divide it by the first one. And that would basically be R, right? So we'll do that with these guys. So that would be 1 plus sine theta over 2 minus 2 cos theta. That is basically going to be my R. And then we can also get R by taking the third one, AR squared, and dividing by the second one, AR. That also cancels out to just R. So if we do that, that's going to be 2 plus 2 cos theta over 1 plus sine theta. And that's also going to be R. So we have two I guess, equations with R. So let's set them equal to each other. And when we set them equal to each other, we get 1 plus sine theta over 2 minus 2 cos theta is equal to 2 plus 2 cos theta over 1 plus sine theta. And let me just see if I did this right here. I think so. All right, so let's cross multiply. So 1 plus sine theta times 1 plus sine theta. And then on the other side, we'd have 2 minus 2 cos theta. And then multiplied by 2 plus 2 cos theta. Okay. So 1 plus 2 sine theta plus sine squared theta. And then on the other side, we got 4 plus 4 minus 4. So those inner ones cancel, but I'm still going to write them out just for the sake of completion. And then minus 4 cos squared theta. Okay, I think we're getting somewhere. Let's see here. I guess we just kind of keep going here. These cancel. And let's see. You know what? I think I'm gonna keep this in the bracket form. I expanded it, but I think I like this better because I kind of noticed like this becomes this right here, right? And then the cos squared theta, you guys remember that famous inequality, or not inequality, sorry, identity, that's what I should say. Identity, that sine squared theta plus cos squared theta equals 1. So that basically means that we can substitute 1 minus sine squared theta. Yeah, and then we get it all in terms of sine theta. So that would be helpful. And let me just see. 1 minus... Or... That's fine. That's fine. So this is going to be 4 minus 4 plus 4 sine theta. Sine squared theta. Yeah, and then I think keeping it in the bracket without expanding it makes it a little bit easier. Because now we just have this guy right here. Okay, now I think we can, since we all have it in one, we just have sine. We don't have any coses, so we can make this work. Okay, so there's going to be two directions. The first is when we take the square root of both sides, it's going to be like that. And then the other one is the minus part. So 1 plus sine theta would be minus 2 sine theta. Yeah. So this one gives me 1 is equal to sine theta, and this one gives me 1 is equal to minus 3 sine theta, I believe. So this one would be sine theta. Did they give us any kind of parameters here? Determine all possible exact values of cos theta. Okay, well, let me just see here. Well, the sine graph, you guys remember, kind of goes like this, right? It just keeps on going. So and this is 1 and this is negative 1. So when you have sine theta equal to 1, that means theta would be equal to this guy right here, and this guy, and so on. So that's going to be 90 degrees, and then the next one would be 360 plus 90, which is 450, and so on, dot, dot, dot. Over here, this will be minus 1 over 3 sine theta. So that, well, I guess we have to figure this out. Over here, if we take the cos of these guys, it's always going to be 0, whether it's 90, 450, or any kind of, subsequent value. So this is one possible answer. And let's get the other one. So if the sine of theta is negative 1/3, again, we go back to that famous identity that cos squared theta plus sine squared theta is 1. So we'll plug this in here to see what we get. So cos squared theta would therefore be, let's see, that's 1 over 9. So cos squared theta would therefore be 8 over 9, right? And then therefore if we take the cos, that's going to be the root of 8 over 3, which is plus or minus. So plus or minus 2 root 2 over 3. Plus or minus 2 root 2 over 3. I believe that is correct. So these are the values right here, and then these two guys right here. "12 points are equally spaced around the entire circumference of a circle. In how many ways can 3 of these points be chosen so that the triangle that they form has at least 2 sides of equal length?" Let us, I'm not sure how many diagrams we're going to need, but let's put 5, and let's see. 1, 2, 3, 4, and 5. Okay, let's see what happens. Okay, so the key is we have to make isosceles triangles. 2 sides, at least 2 sides. So it's going to be either isosceles or equilateral. Okay, so let's start with the equilateral one. That should be fairly simple. And there's 12 sides, right? So that basically means this is like a clock. So that makes it familiar to us since we've all seen clocks. Okay, so equilateral, that would mean, let's see here, there, and there. So if you want to put in terms of the numbers on a clock, sorry, this is totally not drawn to scale. 1, 2, 3, 4, 5, 6, 7. Oh boy, 4, 5, 6, 7, 8. But you guys get the point of what I'm doing here. So this is sort of like my attempt to draw an equilateral triangle. Okay, that's actually not so bad. So that's one way of making an equilateral triangle, and that satisfies the condition of at least 2 sides of equal length, correct? Now, this is obviously just one way, but you could rotate this. You could rotate this, and so for example, here I put the points at 12, 4, and 8. You could also rotate it, and if you did, I'll use a different color. The points would be here, here, and here. That would be the second such triangle, and so on. So what's the total? What's the total number that you'd get? I think you only get 4, because see, if this 12 is sort of like the lead, that lead could be switched and rotated to there, and there. So that would be an additional 3, so total 4. But once you get to here, it's the same triangle again. You see what I mean? So there's really only a total of 4 here. So let's put 4. All right, so let's move on now to what I would believe would be, the rest would be all isosceles. Okay, so here we go. Let's try to do a better job this time of making those points. Okay, so now the first one would be like this guy, and this guy. So that's going to be our first. So that is one example of an isosceles triangle. And this is the 6. That's sort of like I can call it sort of like the head of the triangle. But that could be here, it could be here, and so on. So in total, you'd get 12 here of those kinds of isosceles triangles. The other way of doing it would be, let's see here. The other way is to make the points a little bit farther apart like that. So there you go. And again, this is a 6, and very similarly, you could put that head of that tip of that isosceles triangle at any of the other 12 points, so you get another 12 here. Okay. Moving right along, let's see here. You could also make the tip there, well, as the previous ones, but the other points could be there, and that also makes an isosceles triangle, and very similarly, there'd be 12 of those guys. And then we have the one, if you put here, here, and here, but this guy is the same as this guy. We've already counted that. See what I mean? So don't double count that. So this is already done. Already counted, I guess. Yeah. That's the equilateral. So I guess I have to draw another one to complete the question. Okay, the final one is if you have, let's see here. It would be, let me just make this. So the points would be here, here, and here. And there we go. That's the final type. And there'd be 12 of those guys as well. So that is the way that this is all counted. So we have 4, 12, 12, 12, 12. When you add those up, it's really 4 times 12 plus 4. And I believe that's 52. In the diagram, quadrilateral ABCD has angle ABCD equal to angle CDA equal to 90 degrees. AB is 56, BC is 33, CD is 39, and DA is 52. Point P is on AD, so that BP is perpendicular to AD. Determine the exact length of BP. All right, well, let's see. Let's first connect this C here, straight like that. And I'm going to call that distance Y. And therefore PD will be Y. And then this AP from here to here is 52 minus Y. Let me just set this up here first. And then the distance from this point to B, let's call that X, just from here to here. And everything else is given, so I think it should be enough. So the first thing is in that, and this is the right triangle, x squared plus y squared is 33 squared. So y would be 33 squared minus x squared, all under the square root. And what are we trying to find? BP. So BP is 39 plus x, correct? Yeah. Okay, so I guess we have to, that's going to be at the very end. So our whole task here is to find out the value of x. And because once we get that, then obviously we can calculate BP. Okay, where else can I go here? Let's see here. I guess I can do the triangle BPA, and in that 56 squared would be equal to 52 minus y squared plus BP squared, right? That's a pretty good start. And then I can substitute for y this guy. That way I can get x into the formula. So 56 squared plus, oops, sorry, not plus, equals BP squared plus 52 minus root 33 squared minus x squared, all under this, all squared. Okay, so this is basically just a bunch of terrible algebra. So I'll just try to do it all. 56 squared is equal to BP squared plus 52 squared plus, or minus I should say, 104. 33 squared minus x squared under the square root plus 33 squared minus x squared. Okay, I think there's some hope here. All right, so let's put this guy by itself somewhere, because eventually we're going to have to square that to get rid of the radical. So let's put that, and then put everything else on the other side. So I have 52 squared minus 56 squared. Let's see here. Plus 33 squared minus x squared. And then plus BP. And where's BP? BP's here. But BP, I'm going to put this guy, because I've got to put, obviously, that in there, because otherwise I can't figure out the value for x. Okay, that's pretty good. So now let's clean this all up. Let's see what this all kind of comes down to here. Let's see here. So we got this guy. Uh, 57 and minus x squared plus, oh, we got another one here. 39 squared plus 78x plus x squared. Okay, we're getting there. It's not so bad. I mean, it's bad, but it's not that bad. Okay, so this plus this, that's 2178. Oh, the x's cancel. That's very nice. And then, okay, so it cleaned up pretty nicely there, as long as I didn't make any errors. Okay, so let me just double check this. Hold on. 2178, 78x, 104, all times the root of 33 squared minus x squared. Okay, I probably could divide through by 2. Not sure how much that helps. And that's going to be 1089 plus 39x. Okay, now I think I'm ready to square. Ooh, these are going to be big numbers. Yeah, this is just a algebra question, and it's really just testing your algebraic skills. It's really just Pythagoras. Okay, so let's square all this stuff. So this is going to be 52 squared times 33 squared minus x squared, and then if we square the other side, 1521 x squared plus 84942x plus 1185921. Oof. Okay, so let's expand this guy. 2944656 minus 2704x squared, and then this whole thing. That whole thing, I don't want to write it out again. And then putting everything on one side and collecting like terms, you will get 4225x squared plus 84942x minus 1758735. All right, so we're down to the final step, which is a quadratic, but a terrible quadratic since it's got such large numbers. Minus b, unless you can miraculously factor that, but I don't think anybody can. B squared 84942 squared minus 4ac minus 1758735. Okay, all over 2a, and that's 4225. Okay, and then you crunch out these numbers. I'll let you do that. I'm sure you can. And when you do, you get down to 1,07250 over 8450. There's two values, of course, but x is positive, right? Because x is a distance. So it cannot be negative. So the negative one is inadmissible. So the positive one is the only one you're going to use. And this actually, in lowest terms, is 165 over 13. And then finally, we can go back and calculate BP, which is 39 plus that. So BP, therefore, is 39 plus x, which is 39 plus 165 over 13. And when you do that math, you get 672 over 13. The functions f and g are defined by the values in the tables below. The functions f at minus 1 and g at minus 1 are the inverse functions of f at g, respectively. If f at minus 1 at g at minus 1a is 3, what is the value of a? So these tables are obviously there for a reason. They're going to help us. So first of all, this whole thing here, f at minus 1, g at minus 1a is all equal to 3. So let's take it one step at a time here. Let's just see what would be g at minus 1a. We don't know, but let's just call that something. Let's say it's k. So that means that if we were to switch this, that means g at k is a. That's basically how the definition of an inverse function. If g at minus 1 or g at inverse of a is k, then g at k is a. Okay? And very, very similarly, if you have f at minus 1 of something, whatever it is, like f at minus 1 of something is 3, right? This is basically the something. Then that means that, I don't know what I just put something here. Something. That means that f at 3 would be that something. You guys understand. I just don't want to introduce another variable and make it so confusing. So then that's where we go to these tables. So f at 3 is something. So what is that? When we have 3 for the value of x, f at 3 is 4. So f at 3 is 4. Does that make sense? I hope it does. As long as I did it correctly, it should be. Okay, so then that means, what does it mean? Well, we got to go back to the first one. Oh, what I basically calculated was that this something is equal to 4. And that something is represented over here by this guy right here. Do you see that? You see how here I wrote that word, but it's really corresponding to what's over here. So that basically means that f at minus 1, the whole thing in the bracket is 4. Did you understand why? Something is equal to 4 and something is in there. And that whole thing in here is the equivalent of something. So that's 4 right there. Finally equating, that means that g at minus 1 of a is equal to 4. Using the inverse formula, which I kind of did there, inverse relationship, that means that g at 4 is equal to a. And then that's where we go back to that table. When x is 4, so that's over here, g at 4 is 5. So that means g at 4 is 5, and therefore 5 is equal to a. So as you can see, you just have to kind of know the definition of inverse functions and then use these tables to figure out the values. Determine all pairs xy of real numbers that satisfy the following system of equations. Before I attack this guy here, I'm going to make some substitutions just to make it a little bit cleaner. I'm going to let log of x equal a, and the log of y is equal to b, and these are both base 10. But as you know, when they're base 10, you don't have to write in the base. They did actually, but I'm not going to. I don't need to do that because that's just a kind of a given. Okay, so it makes it a little cleaner. So then the first one is unchanged, like that. And the second one is going to be, let's see here. I made the substitution. It's going to be a squared minus plus 2ab plus b squared is 4. Okay. And that basically is a plus b squared is 4. And this one is the equivalent of, I believe, x minus 4y all squared is 0. Okay. So that's pretty good. And actually from this one we can get x is equal to 4y, because if we take the square root and then put it all on one side, put the y on the other side. So that's pretty good findings. And let's see where we go from there. Yeah. Okay, so let's see here. Where are we going? What's the first step? I think this is very helpful if we use it in coordination with that. Since x is equal to 4y, that means the first one would be log of 4y would be equal to a. Correct? So that basically means that the log of 4 plus the log of y is equal to a. And therefore, the log of 4 plus b is equal to a. If we make that substitution, the log of 4 plus b is equal to a. So that's actually really helpful right there. We got a relationship between a and b. Another one in addition to this one. Okay, so let's move forward with this and see what happens. So where am I going to start? I'm going to start with this guy, obviously. So we have a plus b all squared is equal to 4. A is this, so that's going to be the log of 4 plus b plus b all squared is equal to 4. So therefore, if you take the square root, this is going to be the log of 4 plus 2b is equal to plus or minus 2. So that means that either 2b is equal to 2 minus the log of 4, or it means that 2b is equal to minus 2 minus the log of 4. Okay, so this is 2b using log rules. That's the log of 4 is the log of 2 squared, correct? The log of 2 squared, like that. And then using log rules, you put the 2 out front. You guys remember that, like that. And then you can just divide through by 2. And I think that's as far as we can get. That's very, very good finding. And then we have to do the same thing here. 2b would be minus 2 minus the log of 2 squared. 2b would be minus 2 log 2. And then this would be b is equal to minus 1 minus log of 2. Okay, moving right along. So that's good. And then, of course, we have to figure out a. And a is going to be log of 4, which is 2 squared, plus b. So that's a is equal to 2 the log of 2 plus b. Yeah. So if I put this guy in, it'll be a is equal to the log of 2 plus 1 minus the log of 2. And that becomes the log of 2 plus 1. And if I use this guy, it will be a is equal to 2 log 2 minus 1 minus log 2. So that is a is equal to the log of 2 minus 1. Okay. That's pretty good. And then I forgot what we're supposed to do here. Oh, determine x and y. Okay, that's why, because I had made substitutions. So log of x is a, and log of y is b according to my substitutions. Okay, so let me put that over here. Log of x is a, and the log of y is b. Okay, so here we go. Since that's what I made, I have to calculate x and y based on that. So if the log of x is a, that means that log of x would be log 2 plus 1. So that means 10 to the power of log of 2 plus 1 is x. Right? Okay. The number. You can figure that in your calculator, and when you do, it's 20. That's interesting. Yeah, that's just the number. But somehow, oh, because we got, let me think about this. Log of x is a. We got two values of a. That's why. That one and this one. Oh, so we got to do this again. Okay. I got it. I was wondering. There's something didn't seem right. Okay, so the log of x is a, and we got to use this one as well. So that would be log of 2 minus 1. So the for x over log 2 minus 1 is x. I got it. Okay, is a, I should say. 10 to the power. Hold on. Is equal to x. So again, that's another number. Yeah, that's just a number. So then you can just do that in your calculator fairly easily. And that. Oh, that's undefined. Because that is actually. That's a negative, right? The log of 2 minus 1 becomes a negative. Yeah, log of 2 minus 1 is a negative number. Actually, no, that is... No, it's not undefined. Let me explain that a little bit better. That actually works out to negative 5. X can be calculated, but the reason it's inadmissible, that's the inadmissible. That's probably the better word to use. The reason it's inadmissible is because we were told at the very beginning, I believe, some parameters. And actually, we're not told any parameters. I understand, because look at this equation right here. In that equation, you'll notice they're taking the log of x, and you cannot take the log of a negative number. So it's kind of sneaky how they didn't really tell you that anything like it's got to be positive or negative, but I guess you just have to figure it out that, hey, this is a negative number, and I can't take the log. So, because if you tried to take the log of negative 5, it would be undefined here. Yeah. So that is very interesting. So this is inadmissible. Okay, so the only value we can use for x is 20. Okay, no problem. Now to get y, you just use this guy, x is equal to 4y. So if x is equal to 4y and x is 20, that means y is equal to 5. So after all that big long song and dance, we got that xy has only one solution, and that's 20 and 5.